Illustration of 0-1 knapsack. In the last lecture, we learned about 0-1 knapsack problem and the algorithm that can be used to solve this problem. What we are going to do in this lecture is, we are going to see how exactly is the DP table filled for this 0-1 knapsack problem. We know we have to fill this complete dynamic programming table if you want to find the solution for 0-1 knapsack. How do you fill? You will start from the first block. You will keep on filling in order, and whenever you reach the last block, that is when you have the final solution for 0-1 knapsack. Let us take an example and see how exactly this process of filling happen. Once you see this by taking an example of some certain weights, values and capacity of knapsack, it will be crystal clear for you how this algorithm of 0-1 knapsack is working. Let us go into the example. First of all, what did we learn in the last lecture? What steps should we follow while filling the table? First thing is, let us say you have n different items that are available. So you can fill these items in the knapsack. Capacity of knapsack be W, and let us say we have a DP table called DP of size should be n plus 1 cross W plus 1. This should be the size of the table. Why is it n plus 1 and W plus 1? Because we know the first row and first column will be 0. So let us see in this algorithm where it is happening. The first step you have to do, this is to create this dynamic programming table, a two-dimensional DP table of size n plus 1 cross W plus 1. This is the first step. What is W here? W is the total capacity of knapsack and n is the total number of items that you have in the knapsack. That is total number of items that you can potentially include in the knapsack. It is your choice whether you want to include or not include. And what about those n items? Each of the n items will have a weight Wi and a value Vi. This is what we learned. What is the second step? Once you have this table, and one more thing, what is the significance of each entry in the table? What is dpij? dpij, that is any particular block in the table, dpij represents the maximum value that can be obtained using first I items using a knapsack with capacity of j. That is, if the total capacity of your knapsack is j, then using the first I items out of the total n items, what is the maximum profit you can make, or what is the maximum value that you can have in the knapsack? That is what dpij says. For complete explanation, please refer to the last lecture where we discussed in detail. What is the second step? You want a base case. What is the base case for you? You know, whenever you have no items in the bag, or let us say the capacity of bag is 0, in both the cases total profit will be 0. So dp of ij, this will be equal to 0 whenever, let us say, for all I is equal to 0, or you can also say for all I and j when either of them is 0. This is the condition. So while we are actually filling, what we'll do is, in the table we'll only have the first row as complete zeros. The first column, even though all the values will be zeros, we need not necessarily keep those initially as zeros. We'll fill them in order. So even if you keep the first row as 0, that should be good enough. What is the next thing? The third step, from here on, you are going to use your recurrence relation. So how do you use your recurrence relation? In matrix form. In a loop, you have to run the following. That is, in each step, what should be the condition? The transition formula should be that if, first condition is, if the weight of this particular item, that is Wi, if Wi is greater than j, what is j? J is the present capacity of knapsack. Then what should you do? Your entry dpij should be is equal to dp of I minus 1 j. So for complete explanation, please refer the last lecture. For now, just understand that this is the case when item cannot be included. Why? Because the weight of the item is more than the capacity of total knapsack. In that case, J is the total capacity of knapsack at this point. Because the weight of this item is more than that, you can anyway not include the item. So whatever be the maximum value possible by using the first I items, if the capacity is J, will be same as whatever is the maximum value possible with first I minus 1 items, because ith item can anyway not be included. Next case is if Wi, if it is not greater than J, then it should be less than or equal to J. In this case, you have two options. You can either include the item or you can not include the item. So we have to consider both cases. What will you do? You will take the maximum among the both values. So you will take maximum of, what are the two things? Okay, I should write it as dp of ij. This is equal to maximum of, what are the two cases? One is that I will not include this item. If I don't include, it will be dp of I minus 1 j. And if I include the item, then I should have the value of item, that is vi, plus what should be the remaining maximum? That will be dp of, with I minus 1 items. Let me write it clearly. I minus 1 items. And what is the maximum possible weight? That should be j minus wi. Why is it j minus wi? It is because the ith item consumed wi space. So whatever is the remaining space, remaining weight that the knapsack can take is j minus wi. And finally, what should you do? Whenever you complete the table, the final entry, that is dp of nw. This will give you whatever is the maximum profit you can make from the knapsack. So keep this algorithm in mind. What we are going to do is, we are going to take an example and we'll try to follow step by step while filling the table. This is what we are going to do. So the first thing, let us say our total number of items n is equal to 5 and our capacity of knapsack W is also equal to 5. That is, maximum weight your knapsack can hold is 5 kilograms. Let us say it is in kilograms. Then maximum weight the knapsack can hold is 5 kilograms. Let us say our 5 different items will have weight and value corresponding to each of the item. We'll have Wi, which is the weight of each item, and Vi, which is the value of each item. What should be the weight and value? Let us say for the first item, I'll draw it neatly here. Wi and value Vi. These are the two values that you want. So you will have 5 items here. And for 5 items, first item has a weight of 1 and value of 2, which means it has a total weight of 1 kilogram and the profit it provides is 2. It can be in any unit. What about the second item? Let us say second item has weight of 2 and a profit of 3. Third item, it has a weight of 3 and profit of 3. Fourth item has a weight of 1 and profit of 0.5. And the fifth item, it has a weight of 1 and profit of 1.5. Let us say these are the 5 items that you are having. What do you want to do now? You want to see which of these items will actually get included in the knapsack. Let us start filling the table. How should your DP table look like? It should be a n plus 1. Okay, it should be n plus 1 cross W plus 1 table. This is what we learned. What is n here? 5. W is also 5. So your table should have total of 6 by 6. That is total of 36 blocks should be there. Let us draw the table first. 0, 1, 2, 3, 4 and 5. So you have 6 entries. Similarly, 0, 1, 2, 3, then 4 and 5. So you have a total of 6 entries here. Let us draw the complete table here so that it will be easier for us to understand. So this is a DP table. What we are going to do? We are going to fill each of the entries in the table so that we'll understand how exactly is the DP table getting filled in this algorithm. This is what we are going to do. So let us start filling this DP table. First thing, keep this algorithm in mind. For every single item, we are going to follow this. Our first step is done. We already have the DP table. Second step is to make the first row as zeros. Why is the first row 0? What does the first row and column denote? The first row, this says, let us say here you have values of W, here you have values of N. That is, this 0 means 0 items. 1 means first item can be considered. 2 means first 2 items are considered. 3 means first 3 items are considered, and so on. What does these values represent? 0 means at this point, total capacity of knapsack is 0. Here, what does this column 1 indicate? 1 means at this point, total capacity of knapsack is 1. Similarly, total capacity of knapsack is 2, 3, 4, and so on. This is the idea. The first row, it is always 0. The profit is 0. Why is it 0? Because if you have 0 items, then you cannot have any profit. You need to sell at least one item if you want to get any profit, which means whenever it is the first row with all zeros, that is 0 is the number of items under consideration, then irrespective of the capacity of knapsack, whatever be the capacity of knapsack you have, the value total profit will always be 0. The same will be the case with the first column. What about the first column? Here, you know, weight is 0. That is, the total capacity of knapsack is 0. If the knapsack cannot hold anything, then whatever be the number of items you have, you cannot insert anything. So your total profit will be 0. So the first column, this will also be 0. So we are not including now. Okay, we can include now as well. That will also work. Let us say we are keeping first column as 0. In the algorithm that we learned in last lecture, we actually filled the first column also while we were iterating through. It doesn't harm you even if you put it all as zeros initially. Let us go through the algorithm now. In the algorithm, what are we doing? In each step, in order to update the value of dpij, what will you do? First, you will check whether the weight of that item is greater than the capacity of knapsack. If the weight of item is greater than capacity of knapsack, you just take the entry right above it. That is dpi-1j is the entry right above it in the table. Simply copy that entry because whatever be the profit you can make with I items is the same as profit you can make with I-1 items because ith item's weight is more than the capacity of knapsack. So it is as good as not having this ith item. What is the other case? If the ith item's weight is lesser than or equal to the capacity of knapsack, then if you want, you can include this item. So you have two options. You have to choose whichever gives you maximum profit. First option is not include the item, that is dpi-1j. That is same as what we did here. We are not including the item. If you are including the item, then the value of item plus the value that can be obtained using I-1 items, but with a capacity of j minus wi, dp of I-1 j minus wi. Why is this j minus wi? Because you are already including the ith item. You got the value of ith item as an added positive, but the total capacity of knapsack will go down by wi. Okay, so let us try to implement this. In this, what is the first item here? So I'll just number here 0, 1. Okay, I'll number here as 1, 2, 3, 4, 5. That is item 1, item 2, item 3, and so on. Okay, these are items. So you have 5 items in total, 1, 2, 3, 4, 5. We are considering the first item which is having weight 1 and value 2. Okay, this is what we are considering. First thing, we are going to fill this particular entry. So while filling this entry, what is the first thing you have to do? Look at whether the weight of the item wi that is greater than j. What is j here? J is the value of w. So what is the value of j here? It is 1. Is wi greater than j? No, because wi is 1. which is not greater than j. So wi is less than or equal to j. In case wi is less than or equal to j, what can you do? If you don't include this, then what is the case? If you don't include, you have to take the entry right above it, dp I minus 1j. The entry right above it is 0. So either you have to choose 0, or if you include this item, you have to take dp of I minus 1 j minus wi. So what is wi here? Wi is 1. And what is j? J is also 1. So you have to take dp of I minus 1. I is 1, which means I minus 1 is 0. And j minus wi, this plus value of I. This is what you have to take. So 0, j minus wi. What is j minus wi is? J is 1 and weight of the item is also 1. So it will be 0, 0. So dp of 0, 0 column says the entry is 0. But even though this entry is 0, your total value is value of your item plus 0. So this is 0 and value of your item is 2. How is it 2? From here, from the table, you know, value of your item is 2. So 0 plus 2 is 2. So what is the maximum of 0 and 2? It is 2, which means your entry should be 2. What is the next thing? Next entry. While looking at the next entry, same thing. Your item is always here, n is equal to 1. Only your w is changing because you're going next entries in the same row. So your item is always the first item, which is having weight 1. That is wi is equal to 1 and value of I, vi is equal to 2. What do you want to do now? You want to check what is the entry in the next row. That is dp of 1, 2. This is what you are going to fill. While filling this, what should you see? Whether the weight of the item is greater than j. J is 2. No, the weight of item is less than or equal to j. If it is less than or equal to the capacity of knapsack, then you have two options. One is not to include. If you don't include, then you have to take dp of I minus 1 j. That is dp of 0, 2. dp of 0, 2 is 0. That means you are not including this item. Then your total value will be 0. Total profit from this knapsack will be 0. Why is it 0? Because the first row anyway corresponds to no items. So it is total is 0. What is the other case? If it is not, you have to do value of ith item plus whatever is dp of I minus 1 j minus wi. So what is I minus 1 here? I minus 1 is your I is 1. So I minus 1 will be 0. So dp of 0 j minus wi is 2 minus 1, which is 1. So dp of 0, 1 is this, which is 0. So 0 plus value is 2. So either you can have 0 or you can have 2. Among these, which is the larger one? 2 is the larger. So you will take 2. So now we are going to fill a bit faster because it will be repetitive. What about the next entry? dp of 1, 3. While entering dp of 1, 3, you have to check the one right above it and the one which is in the same row, but you have to decrease the weight of the item. Weight of the item is 1. So you have to take this one. Either it is the value of the one right above 0, or it is the value of this one plus the value of item. That is, or it is 0 plus 2. Which is larger? 0 plus 2, 2 is larger. So I'll take 2 here. What is the next one? Next entry, I'll do the same thing here. The entry right above it or the entry in the row above it, but having weight less than the weight of this item. Weight of this item is 1. If you decrease that, you will reach this entry. So you have to take either the one at 0, 4, which is having value 4, or 0, 3, that is 0 plus value of the item, which is 2. Which is larger? 0 plus 2, 2 is larger. So you will take 2. Same way, the last entry will also be 2. Let me draw this again here. 0, 0. What is the next entry to look at? Next, you are going to fill row number 2. That is third row. It is having index of 2. So I am going to fill dp of 2 and whatever value is there. What does this mean? This means I am considering the first 2 items to be included in the knapsack. I am considering first 2 items. It is not necessary that I am including the first 2 items. Okay. So what is about the second item? Second item is having weight of 2 and value of 3, which means its weight is 2, Wi is equal to 2, and what is the value of item? Vi is equal to 3. This is the situation. If you take the first entry, it will be dp of 2 and 1. In dp of 2, 1, the problem is J is equal to 1. That is the total capacity of knapsack you are considering at this point is 1. But your item is having a weight of 2, which means you can anyway not include this item because the weight of item is more than the total capacity of knapsack at this point. Because of which you simply have to copy the entry in the row above it. So to write here, you will copy this entry which is 2. So what will happen? You will simply write 2 here. What is the next entry? Next entry is dp of 2, 2. How do you fill dp of 2, 2? This time weight, that is the total weight of knapsack, J is 2, capacity is 2, and the weight of item is also 2, which means you have an option of including that item. Then what do? You look at the row above. That is here you want to fill this. So you look at the row above, which is dp of I minus 1j. 1 is that entry. That is in case you are not including the item. In case you are including the item, then in the same row, you have to take the entry which is having dp of I minus 1, j minus wi. Here wi is 2 and j is also 2. So j minus wi will be this entry, 0. So you have to take 0 plus what is the value of the item? 3. So that is you included the item. So you have value 3 plus the remaining capacity of knapsack is 0. So it is 2 and 3. Among these, whichever is the largest. So 3 is larger. So whatever is the larger, you will put it here. What about the next entry? Next entry is, let me fill this back. Next entry is this here. Okay. dp of 2, 3. How do you fill this? Again, you are going to use the same logic. You have to see the entry right above, which is 2. Either you have to put the value 2 or you have to put the value of this minus weight. So that will be weight is 2. So you have to move 2 blocks. You will reach here. So 2 plus you can have the weight of present item, which is 3. So 2 plus 3 is 5. 2 or 5, which is larger? 5 is larger. So you will enter 5 here. The same way, so you see here, you will get same value 5. Here also you will get 5. The same logic. Next is dp of third row we are checking at. Fourth row, which is having index 3, 3, 1. What does this mean? You are including first 3 items. That is, whatever are the first 3 items, they can be included in the knapsack. That is a possibility. And the total capacity of knapsack is 1 at this point. That is in this particular point. What do you do now? You will try to include this item which is having weight 1 and weight 3 and value 3. Weight is 3, value is also 3. What about this item? If you are trying to include, the weight of this item is more than the capacity 1, which means you cannot include the item at this point. What will you do? You will simply copy the row above. So your value will be 2 here. What about dp of 3, 2? Again, the total capacity of knapsack is 2, which is smaller than the weight of this item, which means you can anyway not include this item. You will simply copy the value of the above block. So 3 will come here. What about dp3, 3? This time weight of the knapsack, that is the total capacity of knapsack, is equal to the weight of the item. So you have an option of including this item or you can not include. What will you do? You will check 1 is the value right above the point you want to fill, which is 5, which means you are not including, you are including only 2 items. Otherwise, what can you do? You can include the value of this item, which is 3 plus whatever can be contributed by the remaining knapsack. That is, whatever is this minus weight 3. So you will move 3 blocks before this particular point. So it will be 0. So 3 plus 0, 3 is smaller than 5. So what will you do? You will keep 5. Whichever is the larger, that is what you want to keep. What about the next entry? Again, same scenario, whatever is the value above, that is 5, and value of this item plus value contributed by remaining capacity. So you have to move 3 blocks, 1, 2, 3. Here the value is 2. 3 plus 2 is also 5. So 5 and 5 both are equal. So the value is 5 only. What about the next block? Next block, again you see, in order to fill this, you will see the block above, value is 5. Either you can take 5 or the value of this item plus move 3 blocks beforehand. 1, 2, 3. Value is 3. 3 plus 3 is 6, which means 6 is larger than 5 here. So you will include 6 as the value here. We are going to look into the fourth item, which is having value 1, weight 1 and value 0.5. Weight is 1, value is 0.5. What about this item? When you check DP of 4, 1, what is the scenario? The total capacity of knapsack is already equal to the weight of the item. So you can either include the item or not include the item. What you will do here, while trying this, you will see the block right above it. That will say you, what if you are not including? Then the total value is 2. If you include it, you have to go 1 block beforehand, that is here. It is 0 plus the value of item. Value of item is 0.5. Which is larger, 2 or 0.5? 2 is larger, so you will write 2 here. What about the next block? Again, the same logic. You will either take 3 or you will take 2 plus 0.5, which is 2.5. So 3 is larger, you will take 3. Here, you will either take 5 or 3 plus 0.5, which is 3.5. So 5 is larger. Again, you will either take 5 or 5 plus 0.5, which is 5.5. So 5.5 is larger here. What about this block? You will either take 6 or 5 plus 0.5, which is 5.5. 6 is larger, so you will take 6. How do you fill the last row? DP of, let us say, 5, 1. While starting with this, when you look at the item, it is having weight of 1 and value of 1.5. So here the value is 1.5. So you have a larger value than the previous item. Let us use the same logic and try to fill the table. While filling the first entry, what do you see? One is the value right above it, which is 2, or the value of item, which is 1.5 plus 1 is the weight of this item. So you have to move 1 block to the left. So 0 plus 1.5 is 1.5. 2 is larger, so you will keep 2. Next one, either it can take value 3, which is right above it, or it can take 2 plus 1.5, which is 3.5, which is larger. So you will put 3.5 here. What about the next one? Either 5 or 3 plus 1.5, which is 4.5. So 5 is larger. What about this block? Either you can take 5.5 or 5 plus 1.5, which is 6.5, which is larger. Next block, to fill this, either you can take 6 or 5.5 plus 1.5, which is 7. So 7 is larger, you will put 7 here. This is how you will fill this DP table. When you complete filling, whatever is the entry in your last block, this particular value is the final profit or the final value you can make out from this knapsack. So now you know the total value that this knapsack can provide you is 7. 7 is the maximum profit this knapsack can provide you. This is how you have to fill the knapsack dynamic programming table for 0-1 knapsack problem. So this should be clear for you. One more thing, before we conclude this lecture, it will be interesting to track and see which are the items that are included in the knapsack. See, you know you included 7 items, and one option is while you were filling, whenever you were including that item, then and there only you could have kept a track of the item that you are including. Then at the end of the algorithm, you can say these are the items that are included. That is one option. Otherwise, let us say you have this table. If you have this table, how can you identify which are the items that are included in the knapsack? You know, total value of the knapsack is 7, but how did you find out this 7? What are the items that contributed to this 7? In order to understand that, there is a very easy idea. The idea is, instead of starting from the first block of the table, This time you start from the last block of the table. And what do you check? You have to make a very simple check, that is whether the value in the block is same as the value in the block right above. If the value in the block is same as the one in the value right above, then what does it mean? If it is the same value as the block right above, that means item I was not included. That is why you are copying the value of maximum capacity using I minus 1 items. That is because ith item was not included. So just by looking at the block above, you can directly say whether this particular item, the ith item, was included or not. If it was not included, you have to move to the block above. Otherwise, for example, here these are not same. 6 and 7 are not same, which means ith item, that is the fifth item, was included in the knapsack. If it is included, what do you want to do? Presently, you are at block DP of IJ, or let us say IW. What do you want to do now? If this is the block you are presently at, from here you have to move to DP of I minus 1 W minus WI. This is what you want to do in case these are not equal. In case both these are equal, what will you do? You will simply move to the block above, that is DP of I minus 1 W. These are the two options you have. In this way you can track. Let us simply track and see. This will be a very good exercise. So first of all, 7 and 6, just look at the block above for this particular block. You know, for the last block which corresponds to the fifth item, the block above it, DP I minus 1J, is not same as DP IJ, which means fifth item was included. So fifth item was included, that is for sure. What do you want to do now? You want to move to DP of I minus 1 J minus WI. Weight of this item. What is the weight of this item? Weight is 1. So you have to move one block to the left. So you are moving from here to 5.5. Once you reached 5.5, let me take a different color so that it's easy. So 7 is one item that is included. Then I reached 5.5. At 5.5, what do I check it? I will check whether it is same as the value in the block above. The block above is having value 5, which means fourth item was also included. So fifth item was included, fourth item was also included. And what is the weight of fourth item? Weight of fourth item is also 1. What will I do now? I'll move DP I minus 1, that is in this row, and blocks, I'll move one block to the left because weight is 1 less. So I reached this block. Now what will I check? I will check whether the block above is having the same value. That is having the same value 5, which means this particular item was not included. So I'll move to this block. So I know this was not included. Third item was not included. Now I'm looking at the second item. What about the second item? The block above it is different. So I'll check what is the weight of second item. Weight of second item is 2. I'll move 2 blocks to the left. I'll reach this block. So at this point, I know second item is included because the value above was not same. What about the first item? The block above is not same, which means first item was also included. Then I'll check what is the weight of first item. 1 is the weight. So in I minus 1 row, I'll move one block to the left. I'll reach here. Whenever you reach this 0th row, you know you are done. You have checked all the items. So what do you know now? Fifth item, fourth item, second item and first item were included. So let us just verify the values if you include those items. If these values are included, fifth item is having a value 1.5, 1.5 and weight of 1. Fourth item is having value 0.5 and weight of 1. 0.5 and weight of 1. Third item is not included. Second item, it is having weight of 2, value of 3. So its weight is 2, value is 3. What about the first item? Its weight is 1, value is 2. Weight is 1, value is 2. So if you add all the weight, 2 plus 1 plus 1 plus 1, that is total is 5 is the weight. We know total capacity of knapsack is 5. So total weight of 5 is matching. What about the value? If you add these values, 2 plus 3 is 5. 5 plus 0.5 is 5.5. Plus 1.5 is 7. So 7 is the total value that you get from the knapsack. which is also right. It is also matching. So this is how you can backtrack and find out which are the particular items that were included by looking at the DP table. So the most important point of this lecture was to show how to fill this DP table. This is the most important part. Once you understand how to fill the DP table, then as an extension, we just showed that if you have the table, how to backtrack and find out which were the items that were included. In the next lecture, what we'll do is, instead of filling this complete table, there is a space efficient method using which instead of this complete matrix, you can use a simple array and do the same thing. That is, you can do 0-1 knapsack problem using dynamic programming in a space optimized manner. So let us see that in the next lecture.